This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome to another series sponsored by the Ministry of Education in the Education Broadcasting Unit and ABS Television, where we are mastering mathematics. Today we have a challenging topic because for the past 2 weeks we were looking at our algebra and we were looking at composition of numbers, putting the things that are alike together, grouping, adding and subtracting them. Then we were doing our linear equations. We also showed you that not everything in this world follows linear equation properties, that we can have what we are calling inequalities. And so that was what we did the last time, to show you that in opposition to linear equations, we can also have inequalities. Suppose we had two variables or two unknown in an equation. Can we solve that? And we are saying yes. And that is why today we're going to be looking at the topic simultaneous equation. In this, we have two linear equations with two variables, and we must solve them at the same time. We use that word at the same time only to mean that at the end of the presentation or at the end of completing this sum, we would have had the answer for our x's in this case and our y. But nothing can be done together. So in order to produce the answers, we have to find the solution for one of them. And in order to find the solution for one of them, we have to eliminate the other one. All right? And that is the process I am going to be taking you through at this moment to show you how it is done. This particular problem has a lovely format because we must give everything and every line we are working a name or a number. So even if in writing up the equation, we are starting out with 3x minus 4y is equal to 5, and this we are calling our equation 1. Secondly, we have 2x minus 5y is equal to 8, and that is known as our equation 2. Okay, so here we go. So again, the topic is simultaneous, S-I-M-U-L-T-A, even spelling and all comes into it, N-E-O-U-S, and that word is called simultaneous equation. Okay, so now we're dealing with the topic simultaneous equations, and it comes in the avenue for algebra, and it is helped really in areas where we know we have people in the physics world and in the mechanics and in technology and in engineering in the workplace, and we are looking to solve two things at the same time. Now, the procedure, we join our line here. Now, the first thing, and listen, because you have to listen carefully, watch, because it is important. We can choose in our equations to say to get rid either of our x's, the variables, or the y's. Okay, the choice is ours. In order to get rid of them, we are going to be making them either zeros or ones. All right? No, but generally it is making them zeros because we want to eliminate them. How do we do this? I can tell you at this, I will do both of them so that you can see in one equation that you can in fact work either your x's or your y's and get the answer. In order to say, so in the first instance, in this case, so this I'm calling case 1, I I am eliminating x. So we are eliminating our x's. All right? Now, we have decided to eliminate the x's. This is how it can be achieved. The number in front of the x, and what did we say we call that number? So these come into play. Okay? The numbers in front of the x. What name did we say? Did I hear you saying the name? Yes, the coefficient. All right? So the coefficient for the x's will guide this process. Listen carefully. The coefficient that is in the x term in the second equation is multiplied with all the terms in the first equation. So this coefficient was 2, so the first equation will be multiplied by 2. The coefficient for the x term will be multiplied by equation 2, so that in this case, the second equation will be multiplied by 3. Let us go through that again. Why are we multiplying equation 1 by 2? Because we are getting rid of our x's, and the coefficient for the x in equation 2 is 2. Then we multiply the all the terms in the first equation by 2. Why are we multiplying equation 2 by 3? Because the coefficient in the first equation is 3. So each term in the second equation will be multiplied by 3. Everything we are doing, we are stating it. So then, once we have done that, we will be here, our procedure goes. So we start the procedure here. And we will be saying 2 times, and we use EQN for equation. So 2 times equation 1, and this is what we're going to get. It would be times 3x minus 2 times 4y is equal to 2 times 5. Okay, I want you to see this visually, but normally in class you just be doing the multiplication and writing your answers at the same time. We're taking our times to do that. You can see, and this equation we will be calling equation 3. Okay, so it assumes a name immediately. It is called equation 3. Again, look and see what we did. We want to get rid of our x's, so the coefficient of the second equation is multiplied by each term in the first equation, and that coefficient is 2. Okay, so the 2 multiplied by each term. If we had that would give us, it is 6x minus 8y is equal to 10. That is what our equation 3 is. So we showed you how you got your equation 3. All right? We will now be repeating the same process for equation 2. And we will be writing, it is now 3 times equation 2. Equation 2. And so it will be, I want you to give you a different color so that you can see. It is 3 times, and it is 2x, and we put back our minus, and it is 3 times, and it is 5y, and that is equal to 3 times, and it is 8. Okay, and this would give us our equation 4. All right, writing it out so that you can see where we're coming from. We did our equation 1, so for here, this would be given 2's would give me 6x, and it is minus 3, 5 would give me 15y, and it is equal to 24. So this is what our equation 4 looks like. Okay, that is the process. Let's just stop. Let's repeat it again, because once you know it, you will know it for life. All right, it is simultaneous equation. Nothing difficult about that. The word we also know. Why is it called simultaneous equation? We're trying to get two values at the same time. So in order to achieve this, we have to eliminate one of the variables we would have had in our linear equation. We can choose which one we are going to eliminate. The coefficients for whatever variable we are to eliminate comes into play. And we can say very easily that you just switch the coefficients. The one for the first equation is multiplied by the second equation, and the one for the second equation is multiplied by the first equation. Each term is done in that fashion. So we have got a very long methods to show you. So in the for the procedure, then we're saying we are eliminating our x's in this case. So then it would be, because the second equation, the coefficient for the x was 2, we're multiplying each term in the first equation by 2. So then that would have given us 2 times 3x, 6x, minus 2 times 4y, would have given us 8y, negative 8y, and 2 times 5, which is equal to 10. And you must label the equation immediately, not just a whole confusion. All right, we do the other procedure where we're going for the second equation, multiplying by 3, because the coefficient of the x term in the first equation is 3. So just 3 times 2x, 6x, minus 3 times 5y, negative 5y, and it is equal to 3 times 8, which would be giving us 24, and that's our equation 4. Now let's write the equation 3, equation 4's together so we can see now what we are actually getting at. This then 6x minus 8y is equal to 10, which was the equation 3. And our equation 4, we had 6x, and it is minus 15y is equal to 24. Okay, and that is 4. Right. Yes. Why did we want to do this with our numbers? Because you can see right away we have identical coefficients at this time. So we can indeed eliminate one of them. Okay? We're going to take a break now, and when we come back, we will go through that whole process of eliminating. All right? So take a break, drink some water, and I'll be right back.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.